What's going on, guys? Tim Odell here, Vice Unlimited, back in the shop, doing another YouTube video. My plans of doing a video, like one a week, it hasn't really worked out like I had hoped. It's crazy how fast these weeks just fly by, and you don't get you don't get things done that you wanted to. But back in the shop, got a little project I'm working on. Thought it might be a good opportunity to make a little video. So if you followed my Instagram lately, you've probably seen a lot of CNC, like machine parts, billet parts. So I've been using this Fadal CNC mill quite a bit and making a lot of different parts, trying to find good reasons to use the machine. So yeah, so I thought I'd make a video, me making a part, and let me show you what I'm talking about. All right, so building this little rock crawler buggy over here. It's a mid-engine or a rear-engine rock crawler buggy, and the radiator's in the back. And so I'm actually building a radiator for it, welding on the tanks on the upper and the lower. And so I thought it'd be a kind of a cool thing to make some billet radiator tanks. So I've seen them used like in Indy cars, Formula 1 cars, that sort of thing. So I thought it'd be a pretty cool thing. So this is the upper tank that I've already made, as you can see. All machined, and what's kind of cool about it is it'll be the radiator tank, but you can see here it's got these little holes here, and that'll actually be the mounting. That's how I'll mount it. So you can see both sides have them. And then here I still need to thread this hole here, but this will take a -20 port fitting. So it'll go -20 port to -20 AN fitting. So I've done the upper. Now I need to do the lower. So that's what we're gonna do. We're gonna machine the lower radiator tank. Kind of bring you guys along for that. The process of some of the cam, some of the design work and the cam, figuring out like the tool paths, and then getting it in the machine and kind of going through the process of machining it. All right. So I've got this rough piece here that I cut. Three by 3 by about 15 1/8 inches. So I'm gonna get this thing in this 8-inch vise here on a set of parallels. I don't know if you guys know what parallels are, but sorry for my mess, but here, these are parallels. So put this parallel actually in the vise like so, and that would actually hold the part up off the bottom of the vise. So you put a parallel on each side of the vise and then set your part on the parallels. And that holds them up, holds it up out of the vise a little bit. So let's do that. Let's get our stock in the vise. I've been using this 8-inch, this big old, this is an 8-inch Kurt vise. I love it because it's big and it really holds parts in here very rigid, so you get less vibration. The downside of that is it's a really big vise. So these parallels are made for a 6-inch vise. So I need to get a set of parallels for an 8-inch vise. I'm going to remove this vise first. All right, got that other vise out of the way. Making sure my parallels are tight. All right, it is in the vise. Sweet. All right, so now next step, we basically need to tell this machine where this material is in space. Right now it has no idea where it is, so you need to do a work offset. Basically, we're gonna measure a corner, a point on this material, to tell the machine where it is. So to help us do that, we're going to use this cool tool. It's called a Heimer 3D sensor. So basically it'll measure this little probe on the end right there. Will measure in 3 dimensions. X, this is X, Y, and Z, up and down. So put that in. There we go. All right. So now we got the Heimer. So now we're gonna come over here with my old school Fadal here, and we're gonna set up a work offset. We'll do the 2. Okay, so now I need to go in the computer and get some information. All right guys, so here is the part we are machining in Fusion 360. See here the kind of how it looks here. So basically there's a strategy to machining a part. Kind of have to think ahead a little bit because you got to decide how you're going to hang on to the part, you know, while you're machining it. So the first thing that I'm going to do is I am going to do the bottom first. So basically that means that the first thing I'm going to do is I am going to do like a facing operation. So this 2-inch shell mill basically will just deck the bottom of the part, so it'll make it perfectly flat. Then I am going to, after that op, I am going to do a 2D contour. So it's just going to go around, it's going to go down 3/4 of an inch, and it's just going to machine the sides. And what that's going to do is give me a good place when I flip the part over. It's going to give me a good place to hang on to the part, and it'll also be a good way to indicate off the side of it to do my next operation, which you'll see that here in a little bit. So the main reason I got on the computer here is I need to find my work offset number. So it is offset number 2. So basically you can see here where those little X, Y, and Z is, that is my work offset. So I need to indicate on the corner of my stock in the mill at that same location. That way the mill knows where the part's at. All right, let's do it. Alright, we got that set. I'm going to put my Heimer away. They are a little fragile. Alright. Alright, so now we found where our part is in space. Now it's time to basically download the program off the computer to the Fadal and then hit the go button. Right, so I like to kind of go back. I like to double check everything, make sure, you know, work offset 2, we're facing it, we're doing the contour, so we're good. So now we're gonna post it. Right, so there you go. That's G-code. That's basically the language that the Fadal reads to make that part. Everything looks good. All right, so let's do it. Got this nifty little fun thumb drive. So this older Fadal, this Fadal's from 1996. Fadal 4020 is what it is. Back in the day, this machine, you know, back in the day it would have been like a floppy disk that they would have used to download programs. One cool thing about the Fadal is that it still has a pretty large following, and so there's some companies out there that still make parts for these things. And so they actually, a company called Calimotion makes a USB drive for the Fadal. So basically you can drip feed information off the USB drive to the machine, which is pretty cool, because then you can use it with modern computers and modern design software. And so yeah, it's pretty sweet. Yep. Right. So I'm kind of waking it up right now. And those are all the programs that are currently on that thumb drive. Okay. So now we're gonna go do now we're gonna pull up the program. So let's see here. Okay, so hit plus. All right. So now doesn't usually just take off like that. Close the gates here. Slow everything down. Usually it gives you the option to hit the start button. This time it didn't. This time I just decided to take off. So that is one interesting with these old machines, as they can be a little quirky. Now I'm ready to go here. I hit the start button, and so on this first run, you always want to make sure you want to hit the stop. I usually stop it right there, and I check it, see how much distance, and it says out here Z it says I have 800 thousandths to go. So I have basically a little less than 1 inch. And if I look down there, that's about what I have, less than 1 inch. So I think we're good. I put my GoPro inside the machine, but I don't have a case for it. All right, so that's op 1, did the facing operation. Now it's gonna change tools and do a 2D contour around the edges. Now it's doing what you would call a spring pass. It's kind of doing a final pass just to take off anything that was left from the tool, you know, the tool deflection. Right. All right, all done. So we decked it, or we faced it. Now it's perfectly flat, and then we did a 2D contour around the edge. So now we got a good square and true place to grab it on the next op. And then when we flip it over, I'll actually indicate off these machined, all these two machined surfaces here. All right, so let's flip it over in the vise, get on to the next operation. I was using the mill earlier today, that's why it's so dirty. What I'm doing is I'm making room. I need to set up a stop. I'll show you what I'm talking about here in a second, but I need to make room for that. On the table, in that vise, I put a 1, 2, 3 block. That 1, 2, 3 block is resting against of the side of the part right there. So what I'm doing is I need to be able to indicate, I need to measure off these two faces, but I've got all this extra material up here in the way. I can't bring the Heimer, that measuring tool, I can't bring the Heimer down here and indicate and pick up these edges. So what I'm gonna do is I have basically just kind of temporarily put a vise on the table. I put a 1, 2, 3 block in the jaws, and so what I'm going to do now is remove my part, and then what I can do is I can actually indicate off of the 1, 2, 3 block, and then I can indicate off of the jaw of the chuck, and I can indicate off the top of the parallels that are holding this part, and that'll give me my work offset. That'll basically tell the machine now where this part is in space. So let's do that. All right, so now I've got my offset set. How do you say that? Offset set? That doesn't sound right. All right, so I just wanted to show you here kind of what I was talking about earlier in the way that I did that work offset. So you can see here that corner is where I indicated. So now when I flip it over and put it in the vise, it'll be right at that spot. So the next op we need to do is an adaptive clearing. So you can see it's gonna go around and it's gonna just basically machine everything that's in the way. And then next operation will be a 2D contour. It'll go around the whole thing and clean these walls here. Then the next op is going to be a finishing strategy that will smooth out all the top and the sides and all that. And then we got a couple final passes here just to clean up some of these flat areas. And that's you know, that's basically the strategy for this operation. Let's see what the runtime will be. Yeah, so the runtime on this operation is 1 hour 20 minutes. So yeah, so obviously I'll with the magic of video editing, I'll be able to cut that down a little bit. And but anyway, let's get started on this one. I'll film a little bit of it while it's running, and I'll get back to you when it's done. All right, I'm getting ready to hit the start button. All right, so there you go. That operation probably take 45 minutes, something like that, to rough that all out. Taking about a 200 thou depth of cut and about a 200 thou step over. Pretty safe, but I'd rather play it safe than break tools, which I've done. So you know, one advantage of like the newer machines is the fact that they can remove a lot more material faster. But it's okay. We're not in production here. We're just making cool parts. So yeah. So I'm gonna sit back and actually do some programming on another part that I'm getting ready to do while this is running, and I'll get back with you when it is done. All right, guys. So there is operation 1. So I did the roughing pass, and then it did the 2D contour, you know, around the edges to clean it up. So now it's getting ready to do with the ball end mill here. We're getting ready to smooth out all the roughing. Heck yeah, looks good. All right, now we got the ball end mill going, doing a 3D contour. It's really hard to see, guys. Sorry about that. All right, guys, there you have it. Hour and a half later, that operation is done. Turned out pretty nice. Yeah. So now basically I need to flip it on each side. So I'm going to flip it. I got to do a bore here for the fitting, for the like the inlet, actually the outlet of the water. So I'll do a fitting here. So I got a bore. So I got to flip this thing on its side. That'll be the next step, and then do the bore for that. And then once we get that done, then we have to come to the ends down here, and I got to drill and tap a couple holes in each end to mount the radiator. But yeah, that turned out really nice. Right, let's get this thing flipped around. Yeah, nice. All right, let's do the bore. Right. Let's see how she looks here. Good. So now we have the bore. And then I faced it. So it's nice and got a nice mirror finish on there. Pretty good. I might need to change the inserts on my face mill a little bit, but it looks pretty good. So now I'm going to, next op will be, I'm going to flip it over and I'm just going to face the other side so it matches, so you get that same finish on this opposite side. And then, yeah, then we'll do some holes in each end. All right, hang tight. All right, so I got the part flipped. I'm just gonna face that opposite side, and then we're gonna flip it upside down and do the cavity, do the inside of the tank. Right, so that side's faced, and it's basically all, let's see, 1, 2, 3, 4, all 4 sides and the top are all done. So now we're gonna flip it over. Actually, next we got to drill and tap the ends on each end. That's a little trickier to do, but you'll see the process next here. Right, success. Okay, so we got the part flipped. Now we're gonna do the face and drill some holes, and then after that we will, like we did on the other side, we'll tap them out. Last operation will be to machine the underside, the inside of the tank, and get all this material out from inside. So, all right, let's do it. So since I have everything mocked up here, I need to tap these holes. To do that, I'm going to use this little spring-loaded center, just in a drill chuck, nothing fancy. I don't have room here to tap it with the machine. Normally I would just tap the hole using, you know, just a tap holder and tap it, but I don't have enough Z height here to do that. So I'm going to use this little spring-loaded guy, and that'll guide my tap into this hole, and I'll just tap them by hand. And so what I like to do is get the tapped hole started with like a, just kind of a conventional tap, only because it's got a center. You see that there? It's got a center in it. So, and then I'll finish the hole with a spiral flute tap, which is also a bottoming, bottoming tap. So you can do threads to the bottom of the hole. Yeah, where's my tap handle? Yeah. And there you have it. That side there is drilled and tapped, and a little light face just to clean it up a little bit. So now we flip it over, do the other side. We've got all sides machined, got the holes drilled and tapped. Now, see here, just finished up those 2 holes. So now we're gonna flip it over on its upside down basically, and we're gonna machine basically the inside of the tank. So now I got to, I'm actually gonna use two vices. I'll use the 8-inch vise along with a 6-inch vise, to hold this thing pretty rigid. Once you start machining, you're basically machining away the rigidity of the part by machining the inside of this tank out. So you want to make sure that you've got plenty of support, or else you can get some pretty excessive chatter and that that sort of thing. So that's what we're gonna do next. Get this thing unclamped, move the vices around, and we'll get this thing all clamped up. And then I'm gonna take a lunch break because I'm hungry, and then after lunch, machine the sucker. Alright guys, back from lunch. Got this thing flipped over, upside down. So now we will machine this whole cavity out. Alright, let's get started. Alright guys, been about an hour later, and this thing is done. Yeah, so let's get this thing unbolted here, or unclamped I should say, and see what it looks like. Here we go guys. She is all carved out. Turned out pretty nice. Have to say, that is a nice part. So you see there's a little bit of you know, it's not smooth in here, but it doesn't have to be. You know, this is for water to flow through inside, so it's not real critical as far as having it be perfectly smooth. So that'll work just fine. So the only thing I have left to do is I gotta tap this hole with this big old tap here. So I gotta tap that so that I can put this -20 fitting in here, and that's it. So do that here next, and then weld these puppies on the radiator and get this radiator mounted. So, all right guys, so there you go. Hope you enjoyed that. I know it's kind of hard to see with the coolant and that sort of thing, but there's that part. I think it turned out really good. The finishes are really great, especially for a 20-some-year-old machine, you know. But yeah, so that's actually the lower tank. It's got the cool -20 fitting there, the threads right in, and yeah, so that'll be the lower. I've already done the upper. So now, all right guys, so I edited the whole video for this radiator tank that we built, and I realized in the last shot my GoPro died. So just wanted to show you guys the finished product of this radiator tank that we machined. So let's walk over to the buggy here and let's check it out. Right, let's walk over here and see what it looks like. So since I filmed that video, I was able to basically weld the tanks on the radiator core. So see here, everything's welded up. Got it mounted in the chassis. The -20 fittings up there. Come on, camera, focus. Yeah, my GoPro totally died. It won't turn on, so I'm using a different camera. Anyway, but yeah, so that's how it turned out. So got it in the chassis here, got it mounted down here, and it's looking good. So now I'm doing exhaust on this. This is like a competition rock crawler buggy. So, all right, so just wanted to show you guys kind of the final product of that radiator, the radiator tank build or little project there. So hope you liked it. You guys please like and subscribe if you would. It helps a lot with the channel. I want this thing to grow, motivates me to keep going. So if you would, that'd be great. All right guys, catch you on the next one.